In this video, we are going to look at combinations of transformations. So these are the transformations we've already done, just put together in groups instead of one at a time. So I thought it would be helpful for us to look at an equation like this, and our y equals f of x, that's going to be our parent graph. So for example, if f of x is x squared, that's a parabola with the origin as the vertex. Or we might have f of x equal to x cubed. Well, that would be the x cubed shape with that curvature change at the origin. You remember where it changes, the graph changes the way it looks right there at the origin. So if we have this, then the letters A, C, and D do something to our parent function of f of x, and that's what we're going to look at in this video. What is that something that they do? So A is a multiplier. It's here in front of the f, and you remember our multipliers are stretches and shrinks, and they might be reflections. So if our A value is greater than 1, then we have a vertical stretch. If our A value is in between 0 and 1, then we have a vertical shrink. And if our A value is negative, then we have a reflection. So if A, for example, is -7, the negative part is going to be a reflection, and the 7 part is greater than 1, so that's going to be a vertical stretch. You have to remember to look at the negative as one thing, and then the absolute value of the number as a separate thing. Now I could have a B right here. You'll notice that I skipped that. I did ACD. If I had a B right here, that would be some horizontal stretches and shrinks, and we're not going to do those this year. So that's why I left B out. But I did want you to know that that's possible, and you may run into that in future classes. Okay, C, that's right here. Well, C is added. That tells me it's going to be a translation, and because it's on the inside, it's going to be horizontal. And you will remember that if C is greater than 0, that's going to move us to the left. And if C is less than 0, that is going to move us to the right. So it does the opposite of what you might expect. Now the D that's out here, that's also added. That's going to be a translation as well. But because it's outside the function, that is going to be a vertical translation. And if D is greater than 0, it's going to translate up. If D is less than 0, that's going to translate down. So that moves in the direction that you would expect. Okay, let's look at an example. So I have this one, -2x squared plus 4, our parent graph, the f of x. I can see that x squared in there. So this is going to be a parabola with the vertex on the origin. All right, so there's our parent graph. And now let's look at what all these numbers do to our parent graph. So the negative here, that negative is our reflection. Remember, we have to see the negative and the 2 as two totally different things. The 2 is greater than 1, so it is going to be a stretch. That's a vertical stretch. And the 4 is added. That tells me it's going to be a translation. So is it added inside the function or is it added outside the function? Well, it's added outside the function. So that tells me it's going to be a vertical movement. And when I add, I'm going to be moving up. So what I'm going to do is I'm going to take this parabola with vertex right here at the origin. I'm going to flip it over and I'm going to stretch it, which is going to have the effect of pulling it in and making it thinner. And then I'm going to move it up 4. So the vertex is going to end up being here. And then I'm going to have a thin parabola from that point. All right, there's my thin parabola coming from the vertex there at 4. All right, let's look at some key features. So I asked Desmos to graph that for us. It might be a little bit easier to see the key features from the Desmos graph. All right, domain. So these arrows tell me it's going on and on forever left, on and on forever right. So my domain, -infinity to +infinity. All right, how about the range? Well, range is bottom to top, so I see that I'm going forever down, but I'm going to end right here at 4. So my range is going to be -infinity to 4. 4 is included because I actually reach 4. All right, how about my y-intercept? Do you remember that to find the y-intercept, you put 0 in place of x? And I'm going to end up, if I put that in my calculator, with a 4. So my y-intercept is the point 0.04, which you can see right here. All right, positive. Where is the graph positive? Well, it's positive above the x-axis. So to know where it's positive or negative, I need the x-intercepts. And if you remember, to find the x-intercepts, we put 0 in place of y, and then we solve that. And just to save time, I went ahead and solved that for us. We've got negative square root of 2 and positive square root of 2. So this value is negative square root of 2, and this value is positive square root of 2. So that means that my graph is positive. It is above the x-axis from here around over to here. So my interval is negative square root of 2 to positive square root of 2. All right, so then where is it negative? Where is it below the x-axis? I can see that it's negative here and also negative here. I'm going to have two intervals where it's negative. The first one, negative infinity to negative square root of 2. Okay, that takes care of this first one that's right here. And then I'm going to union that with the second one. So I'm going to kind of write up here. I'm going to union that with the square root of 2 to infinity. And I put parentheses on both of those because actually at negative and positive 2, my graph is 0, which is neither positive nor negative. Okay, increasing. So what does increasing mean? Well, increasing means it's going up. And as I move across the graph from left to right, I can see that it's increasing right here. So that increasing value is from negative infinity up to that vertex. And I always want to use my x values. So that's going to be 0. And then decreasing, well, that's here. Decreasing on the other side of the vertex. And that's from 0 to infinity. Notice I had to scratch out. I tried to use the 4 there, which is a y value. Some of y'all are making that mistake. So I scratched it out and put the x value. Remember that all of these intervals, except for range, are based on x values. All right, let's do another one. Let's look at what happens when I have a cube root. Okay, so my cube root graph, that's going to be my parent graph. And you remember it has that inflection point. It has the point where it changes curvature on the origin. All right, so here is my parent graph. And let's see what all these different things are going to do to it. Well, I have a multiplier here of 3. 3 is greater than 1, so that is going to be a vertical stretch. No flip this time because it's positive. My plus 1, okay, well, that's going to be a translation, and it's inside the function, so that means it's going to be a horizontal translation, which goes the opposite of what I think. So that's going to be left. And then the negative 2 out here, that's outside of the function. That's a vertical translation. So that's going to move me down to exactly what I would anticipate. Okay, so let's see what's going to happen to my turning point, or not my turning point, my inflection point right here on the origin. So if I stretch this by a factor of 3, the graph is going to get taller, but that's not going to affect this particular point because it's on the axis and I'm stretching from there. So it's pulling out on both sides, but it's not necessarily affecting this point. That point is, however, going to translate 1 unit to the left and 2 units down. So I'm going to take this point, go 1 unit to the left and 2 units down. So it's now going to be here. All right, that's this origin point moved down there. And then from this point, I'm going to have this same shape except much taller. So it's going to go out like this. Do you see how much taller I'm making that? And kind of down like that. Still going on and on forever in both directions. All right, let's look at some key features of that one. So again, I have asked Desmos to graph this one for us. There's that point that we moved at -1, -2. All right, so domain. Well, let's look at our arrows. It goes on and on forever left, on and on forever right. So that means the domain is all real numbers. All right, how about range? Range is bottom to top, on and on forever down, on and on forever up. That's going to be all real numbers also. All right, y-intercept. So to find out where this one crosses the y-axis, I'm going to substitute in 0 for x. All right, and let's see. 0 plus 1 is 1. Cube root of 1 is 1. 3 times 1 is 1. Minus 2 is 1. And I can see that right there is the point 0, 1. That's my y-intercept. Okay, so positive. Remember, for positive and negative, I need to know my x-intercept. So that means I put in 0 for y. Okay, and then I'm going to solve that one. And just like I did before, I went ahead and solved this one for us on my calculator to save us a little time. And I got negative 19 over 27. So this point right here is the point negative 19 over 27, comma 0. So positive. What does positive mean? Positive means above the x-axis. So that's going to be this portion of the graph right here. And remember, I only use my x values when I write my when I write my intervals. So negative 19 over 27 up to infinity, right? This arrow tells me it's going on and on forever to the right. And where it's negative, negative is below the x-axis. That's here. So that's negative infinity to negative 19 over 27. Okay, increasing. So what does increasing mean? Increasing means it's going up. So if I look at the graph from left to right, I can see that this one is increasing on its whole domain. So it's increasing from negative infinity to positive infinity. Well, if it's increasing everywhere, then it's not decreasing at all. So I can put none or nowhere. There aren't any, but don't leave it blank. Let me know that you know that it is not decreasing. Okay, let's do one more. This time, let's do this one. Okay, so my f of x, my parent graph, I can see that this one is exponential because I have my x up there in the exponent. And when a is in between 0 and 1, that's going to be exponential decay. So the graph that I have here for us is an exponential decay model. You can see my asymptote right there, and you can see my anchor point right there at 1. So what are all the different things going to do? Well, this one does not have a negative. I don't need to worry about that. The 2 is a multiplier, so that's going to be a stretch. And the 3 is inside the function, so that is going to be a horizontal translation. I'm going to go the opposite way, I think. This one is going to move it left 3. Okay, so my anchor point right here. I'm going to do a vertical stretch. So it's going to move up twice as far as it was. Instead of being at 1, it's going to be at 2. And then it's going to move to the left 3. So that's going to end up being over here. But that doesn't affect my asymptote because my asymptote is here on the x-axis. So when I stretch, things that are on the x-axis don't move. And when I move to the left, well, a horizontal movement is not going to change this horizontal asymptote. So it's going to stay in the same place. So I'm going to take my graph through my anchor point very close right here. Remember, I can be more careful than my technology. I'm not going to touch the asymptote there, even though my technology can't quite show me that that's what's happening. Okay, we're going to do as many of the key features as we have time for. So domain. I can see that it's going on and on and on forever to the left and the right, all real numbers. How about range? Range is bottom to top. So remember, I've got this asymptote right here. So that means the range is never actually touching 0, but it is going up forever. So that's going to be infinity. All right, my y-intercept, if I put 0 right here, 2 times 1/4 to the third, well, that's going to end up being 2 over 64, which would simplify to be 1 over 32. So that's going to be my y-intercept. My asymptote is still that horizontal y equals 0. All right, positive. Where is this one positive? Where is it above the x-axis? Well, all the time, because it never reaches the asymptote, which means it's negative none of the time. It's increasing none of the time. In fact, this one is always decreasing. All right, so that is all the key features of my graph.